Everyone. My name is Martin Joyce, and I just wanted to make a quick video just about um, one of the lessons in Open Up Resources. It's grade 8, Unit 4, Lesson 11, and I also want to talk about how the conversation went with this activity in my class. Although I didn't use Desmos in class to show the work, I'm going to use it to show how students thought about a problem. And in the future, I might use Desmos to help with the synthesis. So first of all, I'm going to look here. Here's the lesson. This is on the website, Unit 4, Lesson 11, on both of the lines. As you can see, students are going to create a graph, and they're going to interpret the graph of the equivalent lines and look at a real-world context here. And also, I want to share some tips that I have about this lesson that can work with other lessons as well. And as you notice, the first activity is a notice and wonder. It's a 10-minute warm-up, and you have to tell the students that there's a picture that shows a ladybug and an ant traveling for 6 seconds. For 1 minute, write down one thing they notice and one thing they wonder. And after that 1 minute, I basically copied and pasted this image. So hit pause on the video and write down or think about what kids might notice and wonder here. And I literally go to my Google Docs and I paste the image here, and I make a little table, and as kids share, I type up what they notice and I put their name in parentheses, and basically did that for all my classes, as you can see here. And that basically gets kids major buy-in to this. And the main thing is that students need to see that one's facing to the right and one's facing to the left, so they're starting at different places. Why are they starting at different places? And that's going to help them in the next activity. I highly recommend, instead of writing this on your whiteboard, what they notice and wonder, typing it up while your screen is projected seems to get kids super engaged and increases access for all students. So after that, and they also can see that the ant is faster, it's covering more distance, and they will cross paths between 2 and 4 seconds because they're a little bit this far apart, and then now they're much further apart and past each other. And they sometimes compare these two pictures, which is a misconception. Each number line is one certain increment in time here. So after we did that, then we actually went over the cool down from the previous lesson, which is this one. Basically, they have to name combinations of 12 coins that total $3, and a combination that makes 12 coins and $3 at the same time. I went through all their cooldowns, and I wrote down people that had a unique answer for number 1, a unique answer for question 2, and then the only correct answer for number 3, because some kids wrote the same answer for all of them, which is the answer to number 3, 12 quarters and 0 dimes. But I wanted to make sure students can see that, the answer to number 1 is all the solutions to this line, which would be the solutions to the equation of this line, as well as for question 2, it's all the ones on the blue line here. And number 3, students, what do you notice about this one? Oh, well, it's like the intersection of the two lines. Therefore, it must be a solution to both scenarios. So from there, that's kind of like how my class starts up. I didn't put it on here too, but before they come in, I have their seating arrangements from Flippity that shows what table number they're going to go to into groups of 4, and then it allows me to switch to groups of 3 later on. So warm up. Then we've reviewed the last cool down, and now we're on to the lesson. Now, if you're not, if you didn't know this, we have at the very top below our lesson preparation, if you click on community created resources, up will pop this. And this is a Google Sheet that right now has the Google Slides for the lesson. And if you click there, you get these Google Slides here. So we go over the learning goal. There's our notice and wonder. We just did that. What do you notice? What do we wonder? And then we launch right into the activity. And here it is. I had a volunteer read this, and I'm going to pause this for now. I mean, I would tell you to pause this if you haven't solved this problem before. I'm not going to go over this too much, but I am going to say this is what their paper looks like right here. Another, excuse me, another interesting thing that recommendation I have for you, especially when the students are working with a graph that has to have precision, go and print out a copy on the PDF downloads for the student task statements, and you can put that underneath your document camera so that students really get a better chance at understanding the graph, and so that you can like synthesize how they thought about it. And the reason why I'm picking this is because some students have a really hard time starting this problem. And so I remind them to think back to the warm-up question, and we give them about 5 minutes. I don't say work by themselves. I say you could start by yourself, but in 5 or 6 minutes, we're going to start talking about the answer to this problem, how to graph the ant's path. And here are equations. They also write an equation that represents the relationship between the ant's distance and have the graph. Usually they do the graph first and then the equation. So now I'm going to go into the Desmos part to this and talk to you about how I thought about this. So that graph is now here on Desmos, okay? So the first thing I ask the students is, okay, let's first label that point they give us. What does 2.5 comma 10 mean? Okay, it means the students will tell you, oh, at 2.5 seconds, they're both they cross paths when they're both 10 centimeters away from the beginning where the ladybug started. My first question to the students, just to warm up their brains, is I say, hey, so what do you notice about this graph that's already on your paper? Is this which insect is this? And they go, oh, well, that's the ladybug because we're trying to figure out the ant. Okay. And so my next question is like, how fast is the ladybug going? And they're like, oh, they're going 4 centimeters a second. And I ask them how, and they say, well, at 1 second, and they see right here, 1 second, it's 4 centimeters. So I also say, well, let's write an equation of that. And like, what do you notice about this relationship? And then they go, oh, it's proportional. I'm like, oh, and all proportional relationships can be graphed how? Oh, that 7th grade equation, right? Y equals kx. So if we write y equals kx, and we know the ant's speed, what's the equation? And they think a little bit, and they're like, oh, well, if it's going 4 centimeters per second, it must be y equals 4x. So then when they put in y equals 4x, we can see that, oh yeah, that's the correct equation. Great. So I make sure the kids write down y equals 4x first, just so they can see that they know the ladybug's equation, but their job is to figure out where's the ant and where's that going to be placed. So then when it's time to synthesize this activity, I go through all the incorrect answers, but that have correct thinking, that show that incorrect answers, there's value in a lot of them, and they can build us towards getting the right answer. So here, the very first thing that kids usually do, or that my class, was they have this line, y equals 2x. So I say to the students, okay, so what's correct about this? And they say, oh, well, okay, it's the right speed because the ladybug's going 4 centimeters a second, and then the ant is going 2 centimeters per second. So y equals 2x is correct. So then I say, well, what's wrong about this? And they're like, oh, well, that means that they're starting at the same place. And we remember from the warm-up question, they don't start at the same place. And I was like, what else is wrong with it? Oh, well, they're not crossing paths. So the ant's going really slow, and the ladybug's going like is going faster. So they're not going to cross. So that can't be right. And I also I actually have I use a ruler to like put my ruler where they go there. So then that doesn't work. Okay, how about y equals 2x? Then this is the next thing they think. Okay, so this is getting closer. So now it's the correct speed. They figure out they do cross paths, but they're both moving in the same direction. That's still not what we want. But it's getting closer to the right idea. And finally, The main thing that